Salinity is integral to understanding ocean properties, water motions, and also to understand a lot of properties related to how marine biosphere operates and how animals and life forms in the oceans are distributed. So salinity along with temperature density decide many aspects of the marine environment. Now, one question that people ask but not as well answered is the question around what is the origin of salts in the oceans? Where does all the salts come from? And this is not a small amount of salt. That's almost 5 into 10 to the power 19 kgs of salts. That's a huge amount of salt, and the amount of salts added to the oceans by the rivers is also significantly higher across every year. So that's approximately 3 into 10 to the power 12 to 13 kg every year. Now, from where does the salts come from? A very old concept is the concept of salt fountains. Just as we have volcanoes that spew out gases and moisture and lava and dust, people thought inside the oceans, on the ocean floor, there are vents. There are certain sources, openings on the floor from where salts keeps oozing out. And they found some salt mounds on the Mediterranean Sea, and they likened that to remnants of ancient salt fountains. But this salt fountain concept is now discarded. What we know today is the primary source of all salts is the rivers and the terrestrial sources. So the winds, the rivers, the glaciers, they erode the rocks of the continent and they deposit those sediments, and those are rich in calcium salts. So rivers, rivers account for almost more than 60% of their composition of minerals as calcium salts. The second very important source are the volcanic eruptions. This include the terrestrial ones, the eruptions, and as they condense, they fall as water on the seas, plus the eruptions inside the water. So the volcanic eruptions are source of sulfide salts, sulfate salts, and chloride salts. Whereas inside the water, there are also a lot of chemical reactions. We have got hot rocks at the locations of geothermal activities, and these hot rocks come in contact with cold water. There's a kind of a flaking reaction where small pieces of the rocks can start disintegrating, and that spreads and remains suspended and eventually dissolved inside the water. So there are some chemical reactions between the water and the rocks that give us potassium and magnesium salts. Now, in this, the most important source is rivers bringing calcium salts, but the rate at which the salts are removed, they again vary from ion to ion. So even if rivers add calcium salts, the oceans actually has very less of calcium salts. If you know some amount of figures here, you'll realize that the oceanic water composition, almost 78% is sodium chloride, whereas calcium sulfate is just about 3.5 to 4%. So my point is, if so much of calcium is being added, where does all that calcium go? And sodium salts are not the most important ions which are being added. But look at the oceans. Sodium salts account for more than 3/4 of the salts, which implies there are some other mechanisms by which the salts maintain their proportions. So there are mechanisms that add salts and there are mechanisms that remove salts. The effective mechanisms for removal is sea spray. Essentially, as the water crashes on the shores, as we have surfs, breakers, so some water gets sprayed on the land, with the water, salts also get thrown, and as water evaporates, the salts remain on the land. So we call those as salt sprays. So that's one way how salts get removed. Biological process. Life forms consume salts from the water, and lot of calcium salts are removed from the water and they accumulate in the bones of the life forms that make up their skeletal systems. Think of coral reefs with their calcareous and calcium carbonate accumulations. And a very important process by which we remove salts also absorption and precipitation. That's very effective for potassium and magnesium salts. What happens is, in the water there are a lot of potassium and magnesium salts. In areas of basaltic eruptions, the basalt kind of interacts with these ions, and these ions get removed and they become a kind of clay with the basalt. I mean, some people suggest that this removal of magnesium and potassium ions by this process is responsible for formation of the polymetallic nodules. I repeat, this is the ocean water and there are basaltic rocks. These basaltic rocks, when they interact, these rocks are capable of absorbing some amount of sodium, some amount of potassium and some amount of magnesium. Sodium is not significant because bulk of it continues to be in the water. But potassium and magnesium are definitely very significantly removed. And with the basalt rocks and absorption of this, they form kind of clay. It's kind of a clay content, and these clay content eventually become like polymetallic nodule precipitates. And that's how the magnesium and potassium which was in the water gets removed. So that's more or less the mechanism how the ocean gets its salts. Some ions get retained in the water and some processes that removes other ions. Now the question is, how do you use all of this? This could be a nice 2 or 3 sentences or maybe schematic as a part of introduction when discussing the salinity patterns of the oceans. This could be a nice 1 paragraph of rich content, maybe show it in a form of a diagram if you want, which can add value to an answer on salinity discussions of the ocean water. So if you want maybe a 10-mark question, what are the important salts of the oceans? Discuss the relative proportion and the sources of such salts. I repeat, what are the important salts of the oceans? Discuss the relative proportion and the sources of these salts. While discussing the proportion, have a table telling us about the relative proportion of sodium chloride, magnesium chloride, calcium sulfate, magnesium sulfate and so on. While discussing the proportion, also have a sentence on the principle of constant proportion. There's some mechanism by which the proportions are managed. Mechanisms are what? Mechanisms related to how we add salts and how we remove salts. So that's about it for this video. Thank you.